Hello and thanks for joining us. Let's derive the formula for the horizontal range attained by a projectile during its flight. For this tutorial, we're going to assume that you've seen our presentation on the 6 basic projectile motion equations in physics. So if you haven't seen it, make sure you check that out first beforehand. And for this particular session, we're also going to refer to the time of flight formula, which has already been derived in another video as well. So you may want to check that out first as well. Let's do it. So hopefully right now you're familiar with this. Here we have a projectile. It is fired from t equals 0 at a velocity v0 in that direction at an angle of theta, okay, to the horizontal. And from t equals 0, the particle is projected and follows this path and comes back down to ground level at this time here. And to derive this horizontal range formula, we're going to assume that we know the time of flight formula. And if you can't remember, there it is, okay? We're assuming it's fired at ground level and lands at ground level, and the time of flight is capital T. And capital T, the formula is 2 times v0 times sine theta, the angle of projection, divided by the acceleration due to gravity. And what are we looking for this time? We're looking for the horizontal range, okay? The maximum horizontal distance that a particle flies, okay, when it is fired from here and lands here. And let's call that maximum horizontal range x max, okay, since x is our variable we're using for horizontal displacement. So as you change theta and you change v0, x max may change as well. Okay, so we're going to derive that exact relationship. And to do that, I'm going to call on one of those 6 basic projectile motion equations. We're going to use this equation. All right, the horizontal displacement formula. So what we're going to do now is take this value for t and put it in here. So in other words, we're going to be doing this substitution. When t becomes the time of flight, the variable t becomes the time of flight, then the horizontal displacement is going to be at its maximum. Let's substitute these into this equation. Okay, so x is going to become x max v naught, okay, and there's a multiplication here and here, times t, capital T is actually our time of flight, so we're going to squeeze this in here, 2v naught sine theta over g, and then multiplied by cos theta. Let's continue this. So x max equals, we're going to try and put it all over a single fraction here. So this is like v naught over 1, so v naught goes on top. 2v naught sine theta, 2v naught sine theta, and then times cos theta at the end. That's like a cos theta over 1, and on bottom just goes g. Let's bring all this together a bit. So x max is going to be, let's put the v0 times the v0 as v0 squared. 2 times sine theta times cos theta. 2 sine theta cos theta. And again, all over that g, which is still there. That's actually it, but we can make this a little tighter. We can make it a little bit more elegant, as mathematicians say. 2 sine theta cos theta can actually be put together a little bit smaller. We could say it like this. There is an expression called sine 2 theta. We call this a trigonometric identity. To be exact, it's actually called a double angle formula. Equals 2 sine theta cos theta. Okay, so whatever theta is, you double it, and then you take the sine of that. It's actually equivalent to 2 times sine of that same angle theta times cos of that same angle. 2 sine theta cos theta can be condensed into just sine 2 theta. And let's do that here. So x max can be simplified to v naught squared. I won't bother writing that times. 2 sine theta cos theta can be rewritten as sine 2 theta all over g. And there you have it. That is the formula. The maximum horizontal range attained by a projectile when fired at an initial velocity v0 and an angle of projection of theta. And an interesting result that can be derived from here is actually to get the maximum horizontal range whenever you're firing a projectile or you're throwing something. The maximum horizontal range can be attained when the angle is actually 45 degrees exactly. How do we know this? Well, let me show you. So sine of anything, okay, if I've got sine of anything you like, okay, there's always going to be between -1 and 1. Maybe you've talked about that, maybe you haven't, but since we're talking about positive angles of theta only, generally we'll just say that at this stage, sine of anything is always between 0 and 1 if you've been doing triangle trigonometry. Okay, but here we're talking about some angle 2 theta. Okay, so the maximum we can get, if we want this to be as large as possible, then we want sine 2 theta to equal 1. Okay, to get the maximum range, we want sine to be as big as possible, right? Sine what equals 1? Okay, hopefully you know that. Sine 90 is 1, which means for the maximum range, this means this angle should be 90. In other words, 2 theta needs to be 90 to get a maximum value for sine 2 theta, which means dividing both sides by 2, theta must be 45 degrees to get the maximum. Okay, so if you want maximum horizontal range, fire it at 45 degrees. That way this value becomes 1, as big as it can be, and your maximum horizontal range will be V0 squared divided by G. I hope you found that useful. Thanks for watching. Please leave a comment if you like, and I'll see you next time.